This video walks through the story of an ionic bond, why atoms seek stability, how metals and nonmetals exchange electrons, how ions attract to form solid crystals, and how the same process can be represented with Lewis dot structures. Atoms are most stable when their outer electron shells resemble those of noble gases, which already have full valence shells. When an atom's outer shell is not full, it is relatively reactive. To become more stable, atoms tend to lose, gain, or share electrons until that outer shell is complete. Metals generally have low ionization energies, meaning it takes little energy to remove their outermost electrons. They therefore tend to lose electrons and form positively charged ions. Nonmetals have high electron affinity, so they readily gain electrons, releasing energy and forming negatively charged ions. When a metal and a nonmetal interact, an electron can transfer from the metal's outer shell to the nonmetal's outer shell. The critical condition is that one atom loses exactly the electrons that another atom gains, allowing both to achieve more stable electron configurations at the same time. After electron transfer, the metal becomes a positively charged cation because it has more protons than electrons. The nonmetal becomes a negatively charged anion because it gained extra electrons. Cations are usually smaller than their parent atoms, while anions become larger due to increased electron repulsion. Opposite charges attract. Once cations and anions form, the positive and negative charges pull toward each other through electrostatic force. This strong attraction between the ions is what is called an ionic bond. It holds the ions together and is responsible for the stability of ionic compounds. In a solid ionic compound, ions arrange themselves in a repeating three-dimensional pattern called a crystal lattice. Each ion is surrounded by several ions of opposite charge. This orderly structure creates hard, brittle solids with high melting points because a lot of energy is required to separate the strong attractions. Lewis dot structures simplify ionic bonding by showing only valence electrons as dots around element symbols. One can depict reactant atoms, the movement of electrons from metal to nonmetal, and the resulting ions with brackets and charges. This symbolic view highlights electron transfer while clearly indicating the final ionic product. To recap, atoms pursue stable electron arrangements. Metals lose electrons while nonmetals gain them, forming oppositely charged ions. Electrostatic attraction binds these ions in a crystal lattice, and Lewis dot structures provide a concise way to represent the entire process of ionic bond formation on paper.